In this section, we will discuss some properties of the image formed by the spherical mirrors. But, without going into any equations, let us start with a concave mirror. And let us say that its radius of curvature is equal to r, and focal length is equal to f. Here we can see that the space around the mirror consists of 4 regions. This region extends from infinity to the center of curvature. This region is between the center of curvature and focus. This region is between the focus and the pole of mirror. And this region is beyond the pole, to the other side till infinity. Let us consider a point object placed on the axis of mirror in this region. If we consider a ray along the axis of mirror, then this ray strikes the mirror at pole and is perpendicular to the surface of mirror at this point. So this ray is reflected back to retrace its path, as the image of object will lie somewhere along the reflected ray, or its extension. So we can say that the image will lie on the axis of mirror. To find the exact location of image, we will need to consider at least one more ray from the object falling on the mirror. However, for the sake of clarity, we may consider more than one ray. Let us consider such a ray. Here the line joining the center of curvature and the point of incidence will be normal to the mirror at this point, as angle of reflection is equal to the angle of incidence. So the reflected ray will be as shown. The point where this reflected ray meets the axis of mirror will be the position where the image will be formed. And as the rays actually meet at this point, so this is a real image. Now, here the point to note is that if the object is at infinity, then we can consider the rays coming from it to be almost parallel and close to principal axis, and the reflected rays will converge at focus, and thus the image is formed at focus. As the object moves towards the center of curvature, then the angle of incidence, and thus the angle of reflection, will decrease. And thus, the image also moves towards the center of curvature. When the object is at the center of curvature, then the incident ray is normal to the mirror at this point, and thus is reflected back to retrace its path. Thus, image is also at the center of curvature. Now, if the object moves towards the focus, then the incident ray goes on the other side of the normal, and thus reflected ray comes on this side. And when the object reaches focus, then the reflected ray becomes parallel to the principal axis, and thus the image is formed at infinity. Note that when the object is in this region, the incident ray is on this side of normal, and thus the reflected ray has to be on this side of normal. Thus, image is in this region. Note that when the object is in this region, the incident ray is on this side of normal, and thus the reflected ray has to be on this side of normal. Thus, image is in this region. And from the principle of optical reversibility, we can say that for a particular position of object in image, we can just reverse the direction of rays to swap the position of object in image. So this symmetry is expected. And this relationship of position of object in image in this region is the exact reverse of the position of object in image in this region. Now, when the object is at focus, the reflected rays are parallel to principal axis. If the object moves closer to the pole, then the reflected rays become diverging in nature, so they cannot meet on this side of mirror. But to an observer, the reflected rays appear to be coming from this point. So this is the location of image, which is virtual in this case. As the object moves closer to the pole, image also moves closer to the pole. Now, a real object cannot go beyond the mirror. But if we just continue this pattern, then incident rays will be as shown, and will form a virtual object, and the reflected rays will become converging, and thus form a real image on this side of mirror. As the object moves towards infinity, the image moves towards the focus. Therefore, when the object is in this region, image is in this region. And when the object is in this region, image is in this region. And from the principle of optical reversibility, we can say that for a particular position of object in image, we can just reverse the direction of rays to swap the position of object in image. So this symmetry is expected. And this relationship of position of object in image in this region is the exact reverse of the position of object in image in this region. Note that if we start with the parallel rays from the object at infinity and make the rays diverging, then the object is real. If we make the rays converging, then the object is virtual. To summarize, when the object is in this region, image is in this region. And when the object is in this region, image is in this region. Here both object and image are real. For this part, when the object is in this region, image is in this region. And when the object is in this region, image is in this region. In this case, here the object is real, and the image is virtual. And here the object is virtual, and the image is real. Now, for a convex mirror also, similar relationship holds. except that the real and the virtual are swapped. Although we will usually consider the convex mirror like this. So a flip version of this diagram will be more useful.